Okay, good morning everyone. Right, welcome to another lockdown lesson. So I'm on quite a tricky topic on equivalent fractions, and we are going to be looking at adding fractions together. For me, one of the most important topics to practice because it shows so much understanding in so many other areas of fractions. So it's a great thing to work on adding fractions because you're revising a lot of different topics just by learning one little question really. So we're going to look at all of that. We're going to hopefully explain why we use equivalent fractions as well, not just give you some methods to use for you to think about it yourselves as always, and really understand the mathematics going on. So to start with, I've got 5 questions to warm up with, some very tricky one at the end based on one of the lessons we've done fairly recently. So let's see what you can do with those, please. 5 questions on different areas of your GCSE maths. Okay, good luck, off you go. Okay, so we're just trying to do those questions there, see if you can work those out without a calculator for everything, please. The kind of questions that, if you want a good grade in your GCSE, you want to be getting these kind of ones correct. You want to be getting good marks on these. These are the ones that come up and you think, right, I know what to do with them. Have I practiced it enough? Have I put enough work in these areas? There's not too much thinking involved, but you've got to make sure you are careful with what you do. So with that word there, it's an annoying word that comes up on exam. It just means work out the answer to. Don't know why they don't just say that, but evaluate means work out the answer to the question. So it's just, what is 4 cubed equal to? And we are going to play a game at the end as well. I know a lot of you have been asking for games. We've been working really hard. It's the few weeks left really till the end of a very strange set of terms of a very strange school year. So we are going to try and put more games and things into these GCSE lessons. if anyone needs any help or anything, please let me know in the chat as well. I think these are some tough ones today. Definitely tough shape to find the volume of. Very tough to get all full marks on that one as well. Probably a 2-mark question nowadays in the GCSE paper. And well, nothing easier though, really. Well done, Daniel, on that last one as well. Good morning, everyone, as well. Right, okay, let's have a look at what you've done with this. So, first one, 40% as a fraction. Okay, so percent means out of 100, so it's 40 out of 100. Now, if you had to simplify, which you do on most of the occasions, and you should do, then that's going to really go down to 4 out of 10, but even then it will go to 2 out of 5. So you're looking at 2 out of 5. Okay? Question 2. Oh. Sorry, that's my 2-year-old. Yeah, very funny, very funny. Off the chair, please. Way. Sorry, just a technical hitch. Thank you. Theo, should be only comprehension now and there. He works on the table. Right, sorry, okay, right, so 4 cubed means 4 times 4 times 4, which is not 12. 4 times 4 is 16. 16 times 4 is 64. Question 3. The volume of this prism. To find the volume of any prism, that's a shape where it's the same all the way through. Find the volume of the first face, the kind of the cross-section face, and then times by how many slices you got, so by 6. So the area of this triangle here is 5 times 4, but you've got to remember to halve it, okay, because it's a triangle, so that gives you 10. You are then going to times your 10 by your 6, so 10 times 6 gives you 60. Don't forget your units, centimetres cubed. Question 4, 3 fifths of 80. So you've got your bar, split it into fifths. 80 divided by the whole lot there is going to be 80 divided by 5 is 16. So 16 in each box. We want 3 of those boxes, which is going to be 48. 48 pounds, in fact, because of the units. And finally, question 5. Expand this bracket is where you times by the 3 and times by the 6. When we talked about fish and chips, ordering things for that one there. So the first bracket is 15x plus 18. You get 1 mark if you got that written down. Hard to get your second mark. This bracket here is negative 4 times everything. So you've got minus 12x, but a negative times a negative is a positive 8, not a negative 8. Then when you simplify that together, 15x minus 12x is 3x, 18 plus 8 is positive 26. So very tough to get the plus 26 there. Okay, so tough section there, but you know, we've been doing these lessons for a while now. I want to challenge you more, I want to give you more complicated maths to do. Right, so this lesson should, for quite a few of you, start quite easy in terms of equivalent fractions, simplifying fractions, and then we'll get into adding fractions as well. Probably won't cover subtracting fractions, but it's the exact same thing anyway, you just take them away instead of add. So to start with, we're going to actually look at some data, okay? We're going to do a bit of data collection just to show you the point of fractions, so what you use it for. So I've chosen some chocolate bars there, some which I think are quite popular, and I want to know, okay, what your favourite chocolate bars are. So we're going to collect some data. We're going to try this in the chat, so you see to post what your favourite chocolate bar is out of those 5. I probably should have put an other option, but I wanted to keep it simple. So post what your favourite chocolate bar is, okay? And then I want you to record your data in some sort of tally chart like that. So record the data. So post on the chat what your favourite chocolate bar is out of those. I'm going to go for Mars bar for that. So that is 1 vote for Mars from me. So I posted mine up there, Mars. So can you post all your favourite chocolate bars and then record them in your own tally charts? Okay, I'm also going to put some more on for the rest of my family because I've asked them already. I've got 1 for dairy milk. So as these come up, you need to record your data as well. So post your data and record it in your own tally chart, something to record this for you there, okay? I'm going to try and record this at home myself as well. Oh, Aero doing very well. Right, so Mars, 1 for Mars. I'm sure you know to do a tally chart. Twix, dairy milk, Snickers, mint Aero again. Snickers and mint Aero. Mint Aero again there. Aero destroying the competition. Okay, so that will be our final data. Just there's a word there. Frequency is basically a word for how many times it occurs. So it's basically your total. So when you see frequency in an exam, it means the total. So we got 1, 2, 7, 1 and 3 for our data there. Okay? So as well as displaying it like this, we're actually going to turn this. Have we got another Twix and a dairy milk as well? Twix and a dairy milk. So we'll go 3 and 2. Okay, I think we're sticking there. Okay, right, so we'll stick there. So that's our data there. So we're going to show this in a bar. Okay, and if you've got the bar printed out, you can do this at home. So what I want you to do is to display this as what's called a segmented bar. So it's a bar cut into lots of pieces, basically. So what you do is you choose a colour for Mars bar. So if I chose black for Mars bar, I could colour in my first bar black like that. So that's Mars bar done. I'll now go on to dairy milk, and I might choose a different colour for dairy milk. So for dairy milk, I'm going to colour in 3 bars blue or purple, whatever colours you want to use. Okay? So can you colour in your segmented bar for this here? So you can draw one. If you haven't got one printed out, you can just draw the bars in there. It's just a really good way of showing what fractions actually are and how you use them in real life with data. So colour in your bar there you've got with a different colour for each one. And make sure you know which colour each one is, or just do them in the same order and we can work it out from there. And I have got a nice bar here as well for me to colour in. Well, green sounds sensible for mint Aero to me. 7. Okay, so I'm just going to show you what I've got for my bar here. So that is my bar there. Okay, so looking at the bar you've got, if I then move on to here, okay, so you've got your bar there. I'll try and show that down, I'm not sure if that will show up or not, but there's the actual bar you've got. Okay, can you now answer the question? What fraction chose Twix? What fraction chose Mars bar? What fraction did not choose dairy milk? So if that's my bar there, okay, can you tell me, answer those questions there? What fraction? And by turning that table into a kind of bar for a fraction, these questions suddenly become really, really simple to do. So what fraction chose Mars bar? What fraction chose Twix? What fraction did not choose dairy milk? So those are your questions there. Okay? So you have a look at the worksheet, don't worry, it's done there for you, that's the bar. So using that bar, so black is Mars bar, blue is dairy milk, green is Aero, red is Twix, and the plain yellow is Snickers there. So what fractions chose each one? You might not need the bar to do that. Okay, so Mars, we've got one, just one person, Mars, which is me actually. Mars bar is 1 out of, and in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1 out of 16 for Mars bar. Twix is 2 bars out of 16, which would cancel down to 1 out of 8. And dairy milk is 3 out of 16. So it shows you the proportions. Okay, it shows you the proportions on this bar. And this will make a bit more sense about why we're doing this later on. One thing you could do, that I think is quite cool, is if you wanted to draw a pie chart, you could actually put your bar into a circle like that, put your bar into a circle, and you could draw your sectors from each of those. So it almost shows you what a pie chart is. A pie chart is just one of these bars curled up. It's all to do with fractions pie charts, so they're quite difficult graphs to draw, but a bit of a cheap way to draw one there. Okay, so similar thing, okay, more onto a GCSE question now. So this time, we've got 2 classes that go on a school trip. We've got a year 8 class and a year 12 class. They go to London, okay, on a trip, and they're going to like different things. So we asked them at the end of the trip, what was your favourite attraction? What was your favourite attraction out of the school trip? Okay, so 10 people from year 8 said Harry Potter, 5 people from year 12 said Harry Potter. So those are the different answers there. So I want to know this. Is London Zoo more popular with the year 8 or the year 12s? Is London Zoo more popular with the year 8s or the year 12s? What do you think? Okay, so more popular, what do you think? Year 8s or year 12s? London Zoo, year 8s or year 12s? Who's it more popular with? Can you tell? Okay, so we say year 8 because there's higher values there. Alright? Makes sense? Let's just have a look at the bars. So I'll put these into bars here. Okay, so there's your London Zoo. So year 8 has 1, 2, 3, 4, 5, 6 of those bars, and year 12 has 5 of those bars. So according to that, it looks like it's more popular. But I don't think this is massively fair, because year 8 had a much bigger class, year 12 had a small class. Okay? Looking at that bar there, if we talk about fractions, it's a bit different. So I think it's very difficult to actually say whether it was more popular with this one or this one based on the different class sizes. So whenever you're comparing things, you want to make sure you've got the same amount of people to compare it fairly. Okay, for example, if I said 1 person out of 2 liked Harry Potter, okay, that's quite popular against those 2 people, that's 50%. If I said 1 person out of 100 liked Harry Potter, that's only 1%. So what we need to do is try and get them out of the same people. So we've got 30 students in this class and 20 students in this class. So I'm going to say, you know what if we had a class of 60 students? What if this class didn't have 30 and it had 60 students in the class? Okay? If it had 60 students in the class, I'm doubling the class size. So if I double the class, I'm going to say, well, if I'm doing Harry Potter World, 10 said that before, and in my new class, it would be sensible to say that 20 said it. And here, 14, 6, 12 and 8. If I'm going from 20 students to 60 students here, can you fill in what you would suggest, how many would like each attraction if there were 60 people in the class rather than 20 people? So can you fill in these boxes there? You can put those on the chat. How will you work out how many do you think would like Harry Potter if there were 60 people in the class instead of 20 people? This is what equivalent fractions is all about. 60 students. So if there were 60 students in the class, instead of 30 students, if there were 60 students in the class, I would say that I think 20 of them would like Harry Potter. I would think 14 of them would like Madame Tussauds, 6 of them would like the Tower of London, 12 would like London Zoo, and 8 would like the Dungeons, if there were 60. Because I've doubled the students in that class to 60. What about this one? If I go from 20 to 60 here, what do you think there should be? Brilliant. Times by 3, you've said there. So you want to times everything by 3, don't you? Because there's 3 times as many pupils in the class. So you're going to expect it to be the same. So you're going to end up with 15, 21, 6, 15, and the London Dungeons is 3. So we said at first, because there were more people like London Zoo in year 8, that it was more popular. But look at this. If the class sizes were the same, we'd have 12 people liking London Zoo from year 8 and 15 people liking London Zoo from year 12. So this is why we need to use fractions to compare things. We can't just compare the numbers because it could be different sizes of totals in there. Alright, if I put that as a bar, okay, we can see again here. So I've done this as a big bar here. So you can see here, we've got this section here, there's your London Zoo, is actually bigger in year 12 than it is in year 8. So this is why we use equivalent fractions, okay, to compare them properly. And it's so important to be able to do that. So we're going to do some basic equivalent fraction work now. It's all about making the denominators the same. So okay, so what I want to say is okay, so if we had this question here, if we had 3/4 was equal to something out of 16. Okay, and this is like your golden rule for equivalent fractions. Okay, whatever we times the bottom by, we times the top by, because we're doubling the class size, we're changing the class size, we're going to change how many people like London Zoo. So if 3 out of 4 people like London Zoo, how many people out of 16 would like London Zoo? Okay, when you're setting these questions out, you want to be looking at what you're timesing by. So if I times 4 to get to 16 by 4, I'm going to times the top by 4 as well, to give me 3 times 4 is 12. So I get 12 out of 16. 4 times 4 gives me 16. 3 times 4 gives me 12. Just have a go at these 2 on the board because we've done quite a bit of this already. So that's question 1. Can you fill in the gaps for these 2, please? So fill in the boxes for me, please. Okay, so can you fill in those six, the missing boxes in those equivalent fraction problems? Look what you're timesing by, or maybe dividing by each one there. Okay, so hopefully you've realised what times each one by. So this one is times by 5, so 35. This one is times by 9, so 27. This one, here we are, if you like, dividing by 2, that's going to be a quarter. This one is times by 2 if you're going that way. So if we go that way, we're going to divide by 2, so it's got to be 4 out of 16. And this one here is times by 4, so we're going to divide by 4 to go back, so it's going to be 3 out of 6. So they're equivalent fractions. If these were class sizes, if we change the class size, we change the amount of people that like Harry Potter. This was how many people liked Harry Potter. Okay, now we want to simplify our fractions, so we want our fractions as simple as possible, and this is all going towards, I hope you find this quite easy, because this is all going to go towards adding fractions, which is a hard bit. So if we've got 12 out of 18, we want to cancel this down. We want this in its simplest terms. So to do that means as small as possible. We want to get the class size as small as possible without going into decimals and everything. So you look for common factors. So you look for a factor of 12 and 18. 2's a good place to start because it's quite easy. You don't need to do it all in one go. So I might say, you know what? I'm going to divide by 2. Divide them both by 2 gives me, well, if 12 out of 18 liked Harry Potter, then it's going to be, instead of 12 out of 18, if I said there's only 9 in the class, I would say it's 6 out of 9. Okay? Don't stop there just because you can't half 9. Well, can't half it without saying is a whole number. We can divide it by 3 because 3 is a factor. So we can divide it by 3 to give me 2 out of 3. 2/3. That is that cancelled down in its simplest form. Always simplify your fractions except for with probability. It's probably the only time you don't need to unless you're told to. Okay, so simplify your fractions. So we're going to have a little go at simplifying some here. I put a few in here that for some reason people really struggle with. I'm not sure why, but they do. So can we cancel down these 8 fractions, please? So can we simplify these into their lowest terms? Okay, so we are cancelling these down, simplifying these into their lowest terms. And just an example for the first one, if we're going to get those down, we find our common factor, which is 2. Divide them both by 2 is going to give me 2 out of 5. So 4/10 will go to 2 out of 5. So see if you can simplify all those. Remember, there are other numbers to use than 2. 2 is not the only factor you are looking for. You're looking for other numbers that go in. If 2 doesn't work, 3 is a good one to try. 10 and 5 are also good ones because they're quite easy to divide by, and it chops it down quite quickly. Okay, so let's have a look at the answers for those questions now. Don't worry if you haven't done all of those yet. We're going to get plenty more practice to look at that later on. So you should have 2/5 for that one, 2/5 for that one, 4/5, 1/4. You could have divided by 20 straight away for that one. 3/7, 7/9. A lot of people get stuck in that one, 11 out of 22, because they think 11 is a prime number, so it's got no factors. But 11 goes into 22, so check if the top goes into the bottom straight away, then you can divide it instantly. 8 does not cancel down, because 37 is a prime number, so it's only factors of 1 and 37. There's no point dividing by 1, because it stays the same, and 37 is obviously not going to go into 22. So not everything cancels down. In an exam, it will normally give you a hint because it will say, leave your answer in its simplest terms, which suggests that there's some cancelling down to do. So watch out for that in the question. It does try and help you, it gives you a hint. Okay, so let's have a look now at adding fractions together. Okay, what is the answer to this? 1/5 add 1/5. What do you think the answer will be to 1/5 add 1/5? Okay, brilliant answers, 2/5. Now, just want to go through this. If anyone was thinking it's 2/10, where you've added the top and the bottoms, okay, this is the kind of answer that you can easily just rush into. You think 1 and 1 is 2, 5 and 5 is 10. Let's just have a look at why that doesn't make sense. If that's 1/5 and that's 1/5, you're saying it's 2/10, that's the same as one of those. So there's no way that 1/5 plus 1/5 equals 1/5. 1/5 add 1/5 does not equal a 5th. So that is clearly not correct at all. The correct answer is this. 1/5 add 2/5 is going to, 1/5 add 1/5 is going to give you 2/5. Okay? So nice and easy, you just add the numerators. However, this only works when the denominators are the same. Only works when the denominators are the same. So if we add 1/8 add 3/8, okay, our answer would be 4/8. Always cancel it down though, because 4/8 will cancel down into 1/2. So make sure we are simplifying our answers in these. Really important to simplify to get that easy mark at the end. And because that's a much better fraction to work with. 1/2, everyone knows what a half means. 4/8 is a bit more hard to visualise, to understand how much of the cake you're talking about. Okay, so the denominators are different though, we've got a problem. So if we add 2/3 add 1/12, we cannot deal with this straight away because we've got different class sizes. So we need to make the class sizes the same. So this is 1 person out of 12. So we'll go back to the Harry Potter thing. 1 person out of 12 likes Harry Potter. 2 people out of 3 like Harry Potter. So let's pretend instead that we had 12 people in that class. So if 2 out of 3 like it, if it was out of 12, I would have to times it. I would need to multiply by 4, because I've got 4 times as many people in the class. So if 2 out of 3 like it, 2 times 4 is 8, 8 out of 12 like it. So 8 out of 12 add 1 out of 12 equals 9 out of 12, which cancels down to 3/4. Okay? So make the bottoms the same, make the class sizes the same. Harder still than that is one like this. So if we add 3/4, add 1/6. We've got a problem here because we cannot get a class size of 4 to a class size of 6 very easily at all, unless we start chopping people up, which we don't want to do. So we find a common multiple of 4 and 6, which we're looking at 12, because 4 goes into 12 and 6 goes into 12 as well. So let's first of all change this class size to 12. So there were 3 out of 4 like Harry Potter. Now we have out of 12, that's times by 3. 9 out of 12 would like Harry Potter. This one out of 12, so we've gone from 6 to 12, we times by 2. So 2 out of 12 will like Harry Potter. We can then add them together to give you 11 out of 12. Okay? So we are adding together the fractions, but we need to make the denominators the same first. This is why it's such a great thing to practice in fractions. You're practicing equivalent fractions, simplifying, and you're adding and subtracting things as well. So let's have a look at some questions of those. So 8 questions on adding fractions together. Okay, see how you get on with those. This is a brilliant topic to master. If you are comfortable with this, that is absolutely fantastic. Okay, they get harder on the second column, but still nothing is easy on this sheet at all. Please write some stuff down as well. A lot of people try to, I've seen someone's got 9 out of 12 for their answer for that one. Have you just tried to do it in your head and just written 9 out of 12 down and forgotten about the rest of the question? Do a little bit of working out. Even if your fraction work is brilliant, it is worth just writing down what you're changing them into. You don't need to write in those times things if you're confident, but write down what you're changing the fractions to and then your answer. Show a little bit of working out. I'm not one for showing lots of working out, but just the jotting so you don't need to remember everything in your head. And then after this, we're going to play the game and then we might look at a couple of exam questions. If you finish those, I'm going to put some extra hard ones on the board, pretty much as hard as you would get in GCSE. So 1 3/7, add 2 4/5. And we're also going to have 2 2/3, take away 1 7/8. So 2 extra hard questions there to have a go at. See what you like with your mixed numbers. If you finish the ones on the board there. You get a variety, you get questions like that and questions like that on your actual GCSE exams. Okay, is anyone stuck on any of these? Make sure you cancel down your fractions as well. Okay, right, we're going to go through these. We're going to do one more question and we're going to play this game. So, answers you should have should be those questions there, okay? This one here, 29 over 24. I've seen someone's went for 48 and got 1 and 10 over 48. That's fine to use 48 instead of 24, but you still need to cancel your 10 out of 48 down to 5 out of 24. So just be careful with that. Always check to see if your answers will cancel down at the end. Even if you're going to a mixed number, it still may cancel. Okay, the tough ones on the board. So, if you're adding together your fractions, you can just do your 3/7 and your 4/5. So that's going to be over 35 and 35. This one, you are timesing by 5, so 15. This one you times in by 7, so 28. Then when you add those together, you get 3 and 42, or 43 over 35, which this will go to a mixed number, so you're going to end up with 4 and 8 over 35. This one here, when you're taking away, I will put them to top-heavy fractions first. And don't worry if you haven't done this yet, I'm just going to show people that have managed this, or are at this level in their maths, what you do. So, you will change this to 8/3 in total, take away 15/8, then you put the bottoms the same, so I go 24 and 24. This one is times by 8, so 64. This one is times by 3, so 45. Take those away, is going to give you 19 out of 24. Okay, so difficult questions, difficult topic. Okay, I've got one more challenge for you. Right, we're back. We best play the game now. Right, okay, right, we're going to play the game now. So what you need to do is we're going to play girls against boys, and it's higher or lower. Okay, so all you're going to guess is I've made some random fractions, I've mixed them all up, and you're going to guess if the next one is going to be higher or lower than 3/4. Now I'm going to take the majority vote from the girls and the boys. Okay, so what I want you to do is we're going to go girls first. So if you are a girl, I would like you to make a prediction. Do you think this card here is going to be higher or lower than 3/4? Higher or lower than 3/4? So any girls out there, can you post on the chat? So we got one for lower there. Any other votes? Going to take the majority vote. So if we have a mixed vote, I'm going to take the majority. I'm going to see once and for who are better, girls or boys. Okay, no problem. I believe you say you're a girl or a boy, that's no problem at all. Okay, so we're going lower for the girls there. So are we going to be lower than 3/4? A half. It's definitely lower than 3/4. So we're going to keep a tally. Everyone you get right is going to be a point. So girls and boys. So girls are in the lead with 1 point. So, oh, tricky one, a half. Higher or lower than a half, boys? Higher or lower than a half? Okay, so lower. We're going lower for boys, are we? Lower than a half. Lower than, if you can just say if you're a boy or a girl, because I've got a delay on this. So we're going lower than a half. Lower than a half. Is this one going to be lower than a half? It is lower than a half. 1/10, boys, tricky one there. Giving an easy one for the girls. Okay, so higher or lower, this is for girls. Higher or lower than 1/10 for girls. Just type whether higher or lower and put G next to your name just so I know it's the right one. Higher or lower than 1/10 for the girls. Easy one, this one. Surely this is an easy one. We got one for higher there. We got one for higher. The one for higher there. So higher than 1/10. We're going higher than 1/10. Higher than 1/10. 9/10. Definitely higher than a 10th. Another point for the girls, leaving potentially an easy one for the boys. Boys, higher or lower than 9/10. Higher or lower than 9/10. Higher or lower than 9/10. What are we going for? Okay, we're going lower than 9/10. Lower than 9/10. 4/5. Is 4/5 lower than 9/10? Well, let's see, we've got 9/10. 4/5. If we got this to 10ths, we would need to times by 2, so 8/10. So it is lower than 9/10, only just lower than 9/10. Well done. Okay, so that was for the boys. So on to the girls again, lower or higher than 4/5. Lower or higher than 4/5. Okay, lower, 4/5. We've got one for lower than anyone else for lower boys. Okay, lower than 4/5. Doing really well so far. Lower than 4/5 for the boys. 7/10. Is 7/10 lower than 4/5? I'm not so sure. So we've got 4/5, 7/10. Well, this would be, we know that's 8/10, don't we? So it is lower, only just lower. On to the girls. 7/10, higher or lower than 7/10 for the girl. That was a girl, wasn't it? Yeah. Okay, so higher or lower than 7/10. That was a boy. No, we're on the boys there. It's Phil, isn't it? We're back to the girl. Back to the girls. Higher or lower than 7/10. Higher or lower than 7/10. Higher or lower than 7/10. Lower. Okay, lower for the girls than 7/10. 1/4. Unbelievable. Who's going to get it wrong first? Whoever gets it wrong first is out. Okay? We are on the boys. Higher or lower than a quarter. Higher or lower than a quarter. Okay, another point for the girls. In fact, we'll pay first. Higher or lower than a quarter for the boys. Higher boys there. Anyone else for the boys? Higher or lower? It's going to be higher than a quarter. Higher than a quarter. Here we go. 2/8. Oh dear. 1/4 is the same as 2/8, and there's nothing for a pair in this game. That old saying goes, so this one, nothing for a pair. So that's no points to the boys for that one. Right, we've got a bit more time left, so girls, higher or lower than 2/8. Higher or lower than 2/8. We're going to play first to 5 points. For win. Higher or lower than 2/8. Higher or lower than 2/8. All the boys said, I would have said higher as well then. Statistically, that's what you want to go for. So we're on 2/8. Higher or lower than 2/8 for the girls. This is for the win for 5 points. What are we going for? So there's a bit of a delay. We're waiting. Higher or lower for the girls? Higher for the girls there, I thought so. Okay, yep, higher for the girls. Higher than 2 8s for the win. 1 out of 100! Well, you can't get much smaller than that, 1%, so it's still no point. So the boys have a chance. Higher or lower than 1 out of 100, boys. I thought the girls had won then. So we got 1 out of 100. Higher or lower than 1 out of 100. One of the girls said lower as well then, but I'm going with the majority. Okay, higher or lower than 100 for the boys to catch up to make it 4 all. 4 all for the boys. Okay, yep, thought so. Okay, higher than 1 out of 100. Nice and easy, nice and easy. Higher than 100. Here we go. 3/5. 3/5, 1 for the boys. So, again, for the win for the girls, higher or lower than 3/5. I've randomly mixed these up, so I have no idea what the answer is. I've not cheated or anything. Higher or lower than 3/5 for the win to prove that girls are better than boys at absolutely everything, not just maths. Higher or lower than 3/5? Higher or lower than 3/5 from the girls? Still waiting for 1 from the girls. I need a vote in. They did get first try, yeah, it's 4 all anyway, it's first to 5. We're going higher than 3/5, higher than 3/5. It's a brave decision, I'm taking the higher. Here we go. 1/3. It's lower for the boys to steal the game. For the boys to steal the game, higher or lower than 1/3 for the boys. Higher or lower than 1/3 to steal the game, despite the girls going first. Higher or lower than 1/3. Higher or lower than 1/3? Okay, still waiting. Higher from the boys, we're going higher for the win. 50%, which is a half, that is higher than 1/3. Well done, boys. Okay, right. Okay, big lesson on fractions there, important to understand them. There's some really good exam questions which I'll attach to this or on the site as well. If you want to have a go at those and send me your answers, I will mark them, or I will post the answers later today or tomorrow as well. Okay, well done for coming back to this. Tough lesson, tough doing at GCSE. I'm sure some of you are going back to school as well. But thank you very much, and I will see you later. And yes, it looks like boys do rule. Well done, boys.